All righty, howdy folks, how we doing? Okay, today we're going to look at our Trig Compositions essential skill, our Arctrig, and this is actually 4.7, inverse trig functions. We're going to actually get through it all in essentially one day, but it is quite a bit here. It's enough to make it its own essential skill because this is one of the big things that you do need to know for calculus, for AP Calc next year. When you get to the very end of the year and you're dealing with derivatives of Arctrig and inverses of Arctrig, you need, or integrals of Arctrig, you need to know how to evaluate those when you get there. So to begin with, just like every function, the trig functions also have inverses. And remember, in order to have an inverse, it has to be able to pass the horizontal line test and the vertical line test. So the vertical line test for a function, and then horizontal to make sure that that inverse makes it 1-to-1. So for every x, there's one and only one y. So what happened here is, if you notice the entire sine curve here, how it keeps curving back and forth, math people said, all right, we need to limit this thing so that way it will pass the horizontal line test. We get as many values as possible, and it includes 0. So that's what they were looking at. How do we have to make this pass the horizontal line test? It already passed the vertical line test, so they needed it to pass both vertical and horizontal line tests. They had to cover the whole range of values. And include 0 in the domain. So they had to go from -1 to 1 for sine and cosine, and they had to include 0 in the domain. So what they did is they came over here and they started from the lowest part, -1, and they tried to go up to create that domain that would cover every y value, include 0, and pass the horizontal and vertical line test. And when they did that, they were able to create essentially these arc values. Now, if you inverse, remember, is where we take our x's and y's. Inverse is where we take our x's and y's and we flip-flop them. So that's why you see them flip-flopped here. And when you graph it, it looks something like this. Now, we're not going to graph Arctrig specifically in our class, but you need to know where the graphs come from. You need to be able to recognize them. So just take the graphs that we have on that closed domain from -π/2 to π/2 and then flip-flop. So the range becomes domain, domain becomes range. And so that's essentially what happened here. And so that's what you're going to kind of see here as we go through this. For cosine, you can see how they did the same thing. Passed the vertical line test and had to pass the horizontal line test. And then, likewise, had to include 0 and go from 1 to -1. And notice cosine went from 0 to pi. 0 to pi. So arcsine's domain would have been from -π/2 to π/2. Cosine's domain will be from 0. Cosine's domain will be from 0 to pi. And then, likewise, they did the same thing with tangent. But notice, on tangent, remember how tangent was essentially a cubic function. In between the asymptotes, you get the entire function, and you get all real numbers. So tangent, the asymptotes are at -π/2 and π/2. So the Arctrig, that'll be its same domain, -π/2 to π/2. And so this is essentially what we end up with. When we're talking about inverse trig or Arctrig, for arcsine and arctangent, and friends, we can go ahead and write on your notes here as well, add in arccosecant and arccotangent. They will all follow that domain from -π/2 to π/2. And again, it gets back to what we saw there and what you have in your notes there on the graphs. So notice, to stay true to the negative, to stay true to the horizontal line test, not only do we go forward, but we had to go backwards. So this down here won't be 3 pi over 2 to 2 pi. We had to go backwards. So this is going to be 0 to negative pi over 2. And we had to go 0 to pi over 2. Now, we're not going to use the left side. And the reason why we're not going to use the left side, go back and take a look at arcsine or sine in general. So if I start here like that, we can't get back over here to 3 pi over 2 to 7 pi, which would be down here somewhere. Because in order to do that, I would have had to have turned the corner. And as soon as I turn the corner, I no longer pass the horizontal line test, which is why we had to spin it backwards. So we are going to go from negative pi over 2 to pi over 2. Now cosine, and you can go ahead and also type in here as well, arcsecant, they're going to go from 0 to pi. So from 0 to pi, because for arc cosecant, and again, think about cosecant for a second. If we think about cosecant, they're going from 1 to negative 1. So here's pi over 2, here's pi. You take the first part of, not cosecant, I'm sorry. If we take the first part of cosine, you can see how it kind of covers everything, and then it starts to come back up. Same thing here, it'll go back down. We just went from that 0 to pi. So we don't deal with quadrant 3 and 4 for our cosine. So all these guys over here, we were going negative pi over 2 to pi over 2. So quadrant 4 and quadrant 1. Arc cosine and arcsecant, it goes from 0 to pi. So we only deal with quadrant 1 and quadrant 2. Okay. The other areas we do not go to. And again, as we start to do this a little bit, it's going to make a little bit more sense to you. So this is just a real quick synopsis about why we're going to limit the things we're going to limit. Okay. So here's how this plays out. And again, it's not too bad. We're just going to go through and we're going to evaluate a bunch of things. The biggest thing to remember about Arctrig is every Arctrig represents an angle. Every Arctrig represents an angle. So whereas trigs represented some side ratio, trig was always representing some side ratio, Arctrig always represents an angle. So trig before, that always was a side ratio, a ratio of sides. Arctrig always represents an angle. So that's what we're finding here on these. We're finding angles. So one of the ways to think about this is just take your trig, arcsine, and make it equal to a theta. Since arctrig is always equal to an angle, make it equal to a theta. Now, since I'm dealing with arcsine, let's think about arcsine for a second. We said the domain is going to go from negative pi over 2 to pi over 2. Which means we won't ever deal with quadrants 2 and 3. So just go ahead and cross those off. Just go ahead and cross those off. We're not dealing with those. So if arcsine 1/2 equals an angle, that means if I were to do the inverse of it, what I'm really looking for here is the sine of theta equal to 1/2. In other words, I'm looking for a y value that equals 1/2 somewhere between negative pi over 2 and pi over 2. That would be this angle right here. You guys are good at the unit circle now. Because this angle right here, and I'm not going to draw the coordinates for the angles all the time. But I will on this one just so you can kind of get the idea of it. Oh, I went the wrong way too, actually. Not good. Let's try that again. So this angle right here on the unit circle, it would have had an x value, which is cosine of √3/2. But it would have a y value of 1/2. Remember that sine is y. We're just trying to figure out where on the unit circle is sine 1/2, or when is y 1/2. Well, that would be at the value of pi/6. So then theta then is equal to pi/6. That's the value that we're looking for between negative pi/2 and pi/2. So we'd come over here and we'd say, well, it equals pi/6. Let's do another one together here. Okay, so another one together here. See how you guys are dealing with these. Then I'm going to let you try a couple here. So arc cosine is -2. So let's think about that one. Arc cosine of -2. Remember, arc always means angle. So we're going to go ahead and we're going to set it equal to theta, because arc always means angle. I'm going to draw where this thing is here. So if I'm dealing with arc cosine, that's going to go from 0 to pi. In other words, I am not dealing with quadrants 3 and 4. So I just go ahead and I'm going to literally shade them out to tell myself, don't go there. So we come back to our arc cosine here. And I'm going to flip it here. Cosine of theta equals -2. Well, friends, I have a problem here. My problem that I have with this one is that I know that cosine of theta, if it's on the unit circle, that means cosine of theta can only be between -1 and 1. I have a domain issue up here with arc cosine, or if I were to do the inverse, I have a range issue. I have a value that does not fall in between -1 and 1. This right here, that doesn't work. That's impossible. So I would have came back over here, then I would have said arc cosine of -2. So that doesn't exist. But I still wanted you to kind of see how we go about setting it up. All right, friends, why don't you guys go ahead and pause the video here and try these next couple. Go for it. All right, let's see how you did. So I'm going to start here. Arc sine of -√3/2. And I'm going to flip it here. So I'm looking for sine of theta equals -√3/2. So I'm going to go to my unit circle now and only deal with quadrant 1 and 4. Go to my unit circle here, only dealing with quadrants 1 and 4. So I'm going to actually cancel out 2 and 3. I don't want to accidentally go there. Can't go there. And when I do that, sine equals -√3/2. Well, that would be down here. Now, I would usually say that is 5 pi over 3. But in this case, I'm not going to call it 5 pi over 3 because that would have made me go all the way through this no-fly area, go through 2 and 4. So I'm going to have to go backwards. So the pi that I'm going backwards to from 0 would have been -pi over 3. And again, -pi over 3 is coterminal to 5 pi over 3. But I need it to fall in my domain for Arctrig. So that means this theta here is equal to -pi over 3. So I can't call it 5 pi over 3. I got to call it -pi over 3. All right, let's see how you guys did on this cosine -1. So for me, first of all, I don't like using inverse cosine. So I'm going to change that to arc cosine. Let's say the same thing. arc cosine of -1. I'm going to make that theta. So cosine of theta equals -1. And I'm sure you guys, some of you guys already can see where it's at, but I like to draw a picture every time anyways. I think it's helpful. I'd like for you guys to go and draw a picture, at least at the beginning, as you guys are dealing with it. Also, if I say to draw a picture, you probably should draw a picture. So I'm going to get rid of 3 and 4 here. And I'm going from 0 to pi. So when is cosine of -1 equal to, or when is cosine equal to -1? Well, friends, that's going to be out here, literally right at pi. So that means theta is equal to pi. So then I come back here, cosine of -1 is pi. Okay, hopefully, I'm hoping you guys are starting to kind of get the gist of this a little bit. So this is the Arctrig part. Let's keep going a little bit. Try a couple more of these here. Let's guys pause the video and see if you guys can kind of play with this a little bit here. All right, let's see how you did. So arc cosecant of 2√3/3. So arc, I see an angle. Oops, I'm starting to draw a theta before I'm ready here. I'm hoping you guys are at the point now where you're able to actually go ahead and know what that is without converting it, but I'll convert in case we're not there yet. Arc cosecant, again, I'm going to get rid of quadrant 2. So it's gone. So that means cosecant of theta is 2√3/3. So that's what I'm looking for. When is cosecant theta 2√3/3? Now, if you're still struggling with the cosecants and the secants and all that, you can convert it if you want to. You don't have to, but if you need to convert it, go ahead. Remember that cosecant is the reciprocal of sine. I'd rather you not have to do that anymore, but if that's where we're still at right now while we're learning the unit circle, that's fine. So I'm going to have to try to see if I can figure out what y value this is. So sine theta, that would have been 3√3/2 times 3. So the 3's cancel out. That means I'm looking for a sine value that is √3/2. So √3/2, sine of √3/2 is at the same location where cosecant is 2√3/3. Well, that, friends, is going to be right here. And that value, that is pi/3. So theta here is pi/3. So then I can come back to arc cosecant and make that pi/3. Arc tangent of -1 equals theta. So our tangent, that's going to still be quadrants 1 and 4. So I'm going to go ahead and get rid of 2 and 3 here. And you guys are going to kind of hopefully see here that it's essentially doing the same thing, a lot of it over and over again. So there's 3 different types of problems really. The first one is just can you go ahead and take an arc value, Arctrig value? So I'm looking for from -pi/2 to +pi/2. When is tangent equal to -1? Friends, that would be down here at 7pi/4, but we're not going to call it 7pi/4. I also use a ray, not an arrow. We're not going to call it 7pi/4. This would be -pi/4 because, again, I had to go from 0 and go backwards. So that means theta here then is -pi/4. So that is -pi/4. All right, so that's the first part. Can we evaluate the Arctrig? The second part to this now is we're going to start to put some things together. What I mean by that is we're going to be dealing with compositions. So whenever I see an arc, we're always going to start inside and go out. So the biggest thing to remember is we're going to go inside and then outside second. So deal with the trig function that is inside first, and then do the outside second. So whatever trig function or inverse trig function is inside, that's going to be what I deal with first. So in this case, inside I see that. Well, that is some sort of angle. So in other words, I'm going to try to figure out the sine of whatever this angle is. Now, sometimes I'm actually going to figure out the specific angle. Sometimes I'm not. Sometimes I'm going to literally draw a triangle that will allow me to figure out the ratio without even determining the triangle or determining the angle. And I'll show you what I mean by that as we go through here. So first of all, we're going to call that theta. So if I go ahead and do my graph here, arc cosine, I get rid of quadrant 3 and 4. And what that means here is that I'm dealing with cosine of theta, which is equal to -1/2. Cosine of theta equals -1/2. Well, that would be right here. That is 2 pi over 3. So that means this theta value I'm dealing with then is 2 pi over 3. So the sine of theta really is actually sine of 2 pi over 3. Because that's what arc cosine of -1/2 would be equal to. And sine of 2 pi over 3, I don't need there's no limiting the domain in here. This is just a regular evaluate a unit circle. That's root 3 over 2. So that would make this root 3 over 2. All right. Why don't you guys pause video and see what you guys can do with the next two, and then we'll talk about it. All right, let's see here. So here I have arc sine equals 3. So that means that's a angle. So I'm going to deal with that first. Now, some of you guys are going to look and say, oh, sine, arc sine, they're inverses. They can just cancel each other out. Well, a lot of times they can, but you still have to confirm and make sure that it's actually okay. Which probably alludes to you that this one isn't going to be okay. I'm hoping you found that. So I'm going to start off here. Arc sine of 3, well, that's equal to theta. So sine of theta equals 3. Well, friends, I don't know about you, but again, just like we saw before with cosine, remember that sine of theta has to be between -1 and +1. There is no way that there is going to be a value that's going to, where 3 would fall this domain. So this one right here, I'm not even going to bother dealing with it. That one is a D and E. I don't have to go there. I don't have to draw my arc sine at all. I don't need to even think about that one. What about this next one? Again, we have ourselves a theta. So what I'm really asking here, friends, is what is tangent of theta? So sometimes, remember I said we can find the angle. Sometimes we can't, but we might be able to find something just as good. So let's see here. We're dealing with arc secant. So arc secant of 7 equals theta. Secant of theta equals 7. Well, that's okay. Because remember, for these values, for arcsecant and arccosecant, those values, it's going to either be our y values can either be from -infinity to -1, or from +1 to infinity, because they are the reciprocal of sine and cosine. So in this case, secant is the reciprocal of cosine. So that's going to be what we're going to end up drawing here. So think about where cosine is. Therefore, that's also going to be where arcsecant is. So I'm going to stay out of this right here. Now, I don't know what that value is. I really don't. What angle is going to give me 7? I don't know, but I can do this to it. What if we made that 7/1? So then I'd be dealing with some r value over some x value. That I can do. So where exactly will that fall? Probably over here somewhere. So I would never actually end up figuring out what that angle is, but I don't always have to do that. So I'm just trying to figure out eventually what is tangent of this angle. So if I can draw a triangle at times, I can pull this off too. So I have 7 for my radius. I have 1 for my x value. Friends, I got to figure out my y value. So back to the Pythagorean Theorem again. So 1 squared plus y squared equals 7 squared. So 1 plus y squared equals 49. So y squared equals 48. And y equals a plus or minus root 48. And which one of these do I want? Friends, I want it to be a positive root 48. So while I can't necessarily figure out this specific theta for it, I didn't really have to, because theta is technically that triangle. So now I can come back here. When I'm asking you for tangent of theta, what's tangent of that triangle? That's root 48, the opposite. That's the wrong color. Over 1, which is the same thing as root 48. All right, friends, so let me go ahead and have you pause the video for a second, because I'd like you guys to try to see if you can actually deal with 4, 5, and 6. In case you haven't figured out the knack today is drill and kill day. All right, go for it. All right, let's see how you did. So notice on the inside of this one, it's just an angle. So I'm going to deal with that angle first. So sine of, or not angle, that's just going to be a value. Sine of 5 pi over 3. There's no arc, trig, nothing here. It's just a straight evaluated unit circle. So sine 5 pi over 3, friends, that would be a negative root 3 over 2, because you guys are unit circle experts. So that means that arc cosine of sine of 5 pi over 3 is really what I'm asking you to do here then is, what is arc cosine of negative root 3 over 2? So in other words, friends, that's a theta. We're going to go ahead and limit our domain here. So think about arc cosine and arc secant. They only use quadrants 1 and 2. So that means cosine of theta is negative root 3 over 2. And where would that fall? Right over here, 5 pi over 6. So notice we're relying on our ability to know the unit circle really well. All right, let's see how you did. If you need to pause the video now to try this one, go ahead and do that. But let's see how you guys did. All right, here we go. Oops, I want to change colors. Let's use green instead. So this one right here, again, it's just going to be an actual angle first. So tangent of 3 pi over 4. That's just going to be -1. So what I'm really asking you here, friends, is arc cosine of tangent of 3 pi over 4 is really the same thing as arc cosine of -1. So I want to figure out what that angle is. Oh, well, it's going to be the same domain we had last time, arc cosine. Oops, not what I wanted. That's what I wanted. All right, so arc cosine, and again, I'm not dealing with quadrants 3 and 4, so we're going to get rid of them. So from 0 to pi, when is arc cosine equal to -1? And we actually already had that one right here at pi. So that means that this right here is pi. So cosine of theta equals -1, theta equals pi. Got to change my width back. There we go. So this whole thing is pi. We start on the inside and we work outside. So on the inside on this one, I have an arc cosine. So apparently we've fallen in love with arc cosines here towards the end here. So arc cosine, let's deal with that to begin with, of 2/3. So every time we see an arc, that is an angle. So cosine of theta equals to 2/3. Well, again, friends, that's not on the unit circle, but I don't necessarily need it to be. Because what I'm really looking here, if arc is some, if arc cosine is some angle, what I'm really looking for is what is the tangent of that given angle. That's what we're asking ourselves here. So this is one of these cases where, all right, I can't necessarily find the specific value, but I could graph it. So arc cosine is positive in quadrant 1. And whenever in doubt, friends, well, no, hold off. We'll get to that in a second. So now we're doing arc cosine and doing it with 2 functions. So that's what makes this a trig composition. So 2/3, that'll be about here somewhere. So this is not on the unit circle, but again, I don't always need it to be on the unit circle. So cosine is 2/3, so that means the horizontal is 2, the radius is 3, and I got to find the y value. So again, we've done this once before, a little Pythagorean theorem here, friends. So 2 squared plus y squared equals 3 squared. So 4 plus y squared equals 9. So y squared equals 5. Get rid of the square, so y equals a plus or minus square root of 5. In this case, I'm in quadrant 1, so I want a positive root 5. So then tangent is opposite over adjacent, so root 5 over 2. All right, so we're getting a lot of practice at this day. We've done 12 problems already. Got a few more to go here just to make sure that we're really getting a lot of practice with this. All right, so our last few here. Friends, why don't you guys try 7 and 8. Just try 7 and 8 first. All right, let's see how you did. Again, start with whatever's on the inside. So I'm looking for some cosine of theta. So arc sine. Every arc means angle. Is -3/5. So that means here, friends, that I'm dealing with sine of theta equals -3/5. So let's draw that up here. We're going to cross off the domain part we don't need. So gone, 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 gone. And if it's -3/5, that means it's going to be down here in quadrant 4. And again, -3/5, I don't have that y value. But I don't need to. Because again, I could actually go through and figure out whatever x value that goes with and just treat it like a triangle again. So even though I'm guessing you guys already know what triangle this is, I'll go ahead and solve it just to clear up any confusion there might be. So -3 squared is 9 plus x squared equals 25. So x squared is 16. So that means x equals plus or minus 4. And in our problem, we want the x value to be 4. So we're taking a positive 4. So cosine theta, that's going to really be the cosine of just this triangle. The cosine of that triangle is a positive 4/5. So we're using our arcs to find our angles, or in some cases, draw a triangle. And then from there, when it's with a composition, you do the inside function first and the outside function second. So notice it is pretty much kind of just this same idea. So I see an arc cosine there, by the way. That's a theta. It's the same idea of just, and we're just kind of doing it over and over again as many different ways as possible. You just have to take your time on it. Don't try to rush it. It takes a little bit of practice. So we are going to spend a couple days on this. But we are essentially doing the same thing over and over again. So arc cosine equals some angle. Arc cosine, that'll be the same thing as arc sine. So I'm dealing with 1 and 4. So I'm going to cross that off there. So that means that I'm dealing with cosecant of theta equals -2. Now, again, I'm hoping that you guys can figure out what angle that is. If you can't, no harm, no foul. If we're not there yet, just do the reciprocal for it. Sine of theta equals -1/2. You can always do the reciprocal for it. So sine of theta equals -1/2. Where would that fall? Down here in quadrant 4, and that's going to be a -π/6. So that'd be a -π/6. So what I'm really asking here is, what is secant, friends, of -π/6? And that would be the reciprocal of cosine. So this is going to end up being 2√3/3. And if we still haven't quite got the unit circled down yet, that's fine. Just treat it this way. Cosine of theta, or negative power 6 would be root 3 over 2. So the secant would be the reciprocal of it, 2 root 3 over 3. And we end up with 2 root 3 over 3. All right, friends. The last kind of thing you could see is when we're not dealing with numbers at all. Now, do me a huge favor on your guys' notes. I want you to get rid of that negative. All right, so how does this work? When we're not dealing with angles at all, or when we're not dealing with numbers at all, we're just going to leave our answer as an expression. So this arc cosine, remember that's an angle. So we're trying to figure out the sine of some angle. So what angle are we looking at? Now the other thing here, whenever you're dealing with just variables, unless you can clearly tell where it's at, even in that regard, go ahead and always leave it in quadrant 1. We're only going to draw in quadrant 1 here. So arc cosine of 3x is theta. That means cosine of theta equals 3x. Now, I don't know where that is, obviously, but what I can do, friends, is I can always turn it into 3x over 1, so, or adjacent over hypotenuse. So think about where arc cosine would be. So we're going to get rid of this right here. But whenever we're dealing with just variables, go ahead and always make it in your first quadrant. So I'm going to make this up here in my first quadrant. So here's my theta. So just like we did with the numbers, now we're doing it with the variables. Cosine is adjacent over hypotenuse. So this is my adjacent side, it's 3x. My hypotenuse side is 1, and I need to figure out what y is. So 3x squared plus y squared equals 1 squared. So 9x squared plus y squared equals 1. So y squared is 1 minus 9x squared. And we are going to do the square root. Now, since I'm dealing with just variables, I'm still going to put a plus, or even though I'm dealing with just variables, I'm still putting a plus or minus in front of it. But since it's always going to be drawn in quadrant 1, just realize it's always going to be the positive square root, 1 minus 9x squared. Okay, so now we know what our triangle looks like. Let's come back to what we were trying to deal with. We were looking at sine. Well, sine is the opposite over the adjacent. So, I'm sorry, opposite over the hypotenuse. So in other words, we had the opposite, 1 minus 9x squared over the hypotenuse, which was 1. So this whole thing right here is the square root of 1 minus 9x squared. All right, why don't you guys go ahead and pause the video and see if you guys can't take a look at these next two. All right, let's see how you guys did here. So that right there is an angle, so secant of that angle. So arctangent of x over root 5 is some theta. So just for the good practice of it, we're going to make sure we draw that appropriately. Where is arc tangent at? That's in quadrant 1 and 4. So we're going to get rid of all that right there. But again, with variables, we're always putting it in quadrant 1. So tangent of theta is x over root 5. Opposite over adjacent. And we're looking for the r value. So x squared plus root 5 squared equals r squared. So x squared plus 5 equals r squared. And then we take our square root, so plus or minus x squared plus 5 equals r. And since it's my radius, it's always going to be the positive version, but I'm also in quadrant 1 too. So x squared plus 5 equals r. So that would be what I would throw up here, the square root of x squared plus 5. So secant theta is hypotenuse over adjacent. So here we go, my hypotenuse, x squared plus 5, over my adjacent, root 5. So x squared plus 5 over root 5. All right, if you need another chance of this one, go and pause it. Do me a favor though, when you get to the m plus h, don't try to multiply that all the way out. Leave that one alone. Yeah. Okay, so let's see how we did here. So that's tangent of an angle. It's our final problem here on this, in these notes, and our final problem in this chapter. So we're dealing with arc cosine of m plus h all over 3k. So that is a theta value. So arc cosine, let's think about where arc cosine is. Just for the good practice of it, that's going to be in quadrants 1 and 2. But again, since it's variables, we're always going to be in quadrant 1. So when we do our cosine here, cosine of theta is m plus h all over 3k. So let's see here. Cosine is adjacent over hypotenuse. So I know my adjacent, that's m plus h. I know my hypotenuse, that's 3k. I'm trying to figure out the y value. All right. So m plus h, we're just going to leave that as m plus h. We're not going to multiply that all the way out. Plus y squared equals 3k squared. So m plus h squared plus y squared equals 9k squared. So y squared is 9k squared minus m plus h squared. And we take the square root of it. And since we are dealing with the quadrant 1, that'll be a positive y value. So we got through 17 examples today, friends. That's a lot of practice on Arctrig. So here we go. And like I said, we'll spend a couple days practicing these the next 2 days. So we got all the notes in 1 day, but we'll practice it for 2 days because it is an essential skill. It's a big thing you need to remember. So my tangent then is my opposite over my adjacent. So 9k squared, that's my tangent. Over my adjacent, which was m plus h. And I really don't need to write this again, but I'll put it up over here just to make sure we know that it's part of the whole thing. All right, friends, so this is Arctrig, and then also trig compositions. They go together. All righty, friends. So, well, like I said, we'll talk about this more in the next couple of days. And I look forward to seeing you guys in class. So, talk to you guys later.